What is up, Rad Potential YouTube? I'm Mr. Rad, and in today's video, I'm going to be turning this crazy bundle of wires into a wiring harness to run my RX7 engine swapped Mazda RX8 that our goal is to make close to 600 horsepower. Now, before you get intimidated by this crazy mess of wires, trust me, by the end of this video, I bet that you'll be confident enough to wire your RX8 yourself with any sort of engine swap, not just a rotary. So you could do this with a K-Series, an LS, anything you're wanting to set up a standalone ECU with a custom harness and some extra data. You're gonna learn something in this video, and I'm excited to get this harness built so I can do a cannonball run in this Mazda RX8 and hopefully reset the rotary engine cannonball run record. So let's get started. The RX8 is lovely. So the RX8 is a very modern car compared to any of the other cars that we work on to this depth on the channel. So I want to walk you guys through exactly my process, parts, the things we're using before we go to install them, such that you can have ECU wiring for basic folks. You can have a little bit of knowledge about how this is all going to work. Okay, so when we're putting the Haltech ECU, I have the Haltech Nexus S3. Small caveat. The plug-and-play ECU for RX8s was not out at the time that I was building my car, and I had already bought this one. This one has a little bit more capability. We're doing this the hard way. There's a plug-and-play option now, tunedbysean.com. I'll talk about that in a second as well, Mr. Rad 5. So my Haltech Nexus S3 has what's called CAN bus, meaning I can send a language out to talk to the RX8's body control module, which is legendary. If you're using an older ECU, a different brand, I'm sure there's other manufacturers. Sometimes the CAN language, the CAN bus language, is not compatible. Haltech, you literally select Mazda RX8, boom, all your gauges, everything inside the body control module is happy. So why is that important? The ECU is not the smartest thing on the RX8 when we're doing this. So that's my ECU. I've got also a Haltech IC7 digital dash, which is not going to replace my factory dash, but this will also be linked to the CAN bus stream. And then I'm completely starting from scratch using a flying lead harness, which is kind of getting a little bit of a head start, but a flying lead harness looks like this. The one I have in the car already doesn't actually have the fuse box. This is for an older Elite style ECU, so don't get too attached to this. But just imagine all these wires come from the ECU. They don't necessarily go to the car. We have to integrate this to the car. And how am I gonna do that? So that's where Tuned by Sean comes in. Sean has this really trick adapter harness, which I already have plugged into the car right up there. Otherwise I would show it to you. I'm gonna put it on the screen. And the adapter harness plugs in to the factory ECU wiring on the RX8. So when you take your stock ECU out, you plug that harness in. The coolest part about this harness is that the harness now links the chassis, my super sexy drawing right here, to my ECU, another super sexy drawing, and then also talks to the engine. So this Tuned by Sean harness connects these two things. The best part about it is that Sean went ahead and figured out all the science for the RX8, meaning what wire in that ECU plug from the chassis is your accelerator drive-by-wire pedal position. What wire is the cruise control? What wire is what we want to use for rolling anti-lag? All those cool things. Regardless of rotary engine, LS engine, K-Series engine, BMW, 2JZ, whatever, if you can run it on a Haltech, you can buy this harness, tunedbysean.com, Mr. Rad 5, 5% off anything on the website, to use in your swap. And this harness makes all of that basically seamless. Sean's going to take you and he will set you up with a base map on how that harness works. And once you buy one, he will then show you how it all is laid out and how you can wire it up. So I've done that and I've got my harness set up. We got my base map set up. So now ECU wiring for basic folks. With his harness, you connect the RX8 chassis to the Haltech ECU. CAN bus data stream working. Gauges, factory RX8 dash working. The ECU, because it's linked to the car, can now see wheel speed. It can see your four-wheel ABS wheel speed stuff. It can see the clutch pedal, whether you have it pushed in or let off. It can see if you have the brakes on or not, because it's talking to the chassis. It can see your pedal position. It's got all that stuff, which is super rad. So the ECU gets the data from here, and the ECU also sends data to the car. Let's talk ECU wiring for basic folks on the engine side. And I want to give you a basic rundown of some simple sensors before I show you where they're at on my car, and then we inevitably have to hook all of them up. The most basic sensor is a 2-wire sensor. It's what's called an analog voltage input, or AVI for short. So on your Haltech wiring harness diagram, this will come with your ECU. Even if you bought a pre-built harness, the guy that makes the harness should send you one of these. It's all filled out with what everything is going to. This is your roadmap. So, analog voltage input. Number 11 is my coolant temperature sensor. That is a 2-wire sensor. It has the AVI, which is a wire to the computer, and it has a signal ground, which also grounds to the computer, so there's a reference therein. As the car heats up, the resistance changes, the ECU displays your coolant temperature. Very, very basic. The next sensor, 5-volt sensor. I'm going to call it a 3-wire sensor. Somewhat more complex, but still using an analog voltage input, AVI. You send 5 volts to it, the resistance changes, boost goes up, the voltage input is reflected in the ECU, you have a ground there. It's 3 wires, that's how that sensor works. Pressure sensors, shock travel sensors, any 5-volt sensor generally is kind of a 3-wire. Very basic. At least at this level, it's all going to be super basic. A more complex sensor, but not the most, is a flex fuel sensor. You actually send 12 volts to that instead of 5. It has a ground, and you're going to actually use an SPI, which stands for synchronized pulse input. Don't let me lose it here, guys. We got one more thing to talk about, and then we're going to jump right to laying the harness out. But an SPI means that the signal wire is not simply resistance. It's actually like little firing electrons in there, bouncing off of stuff, and it reads like the rate of that. It's a synchronized pulse, right? Like imagine you're pulsing something, like your heartbeat. That's what this is reading. It has a different plug on the Haltech, on this side, different connector. SPI, wherever it's at on here. That's DPO. I was on the right side the first time. SPI, right there, synchronized pulse inputs. The last part of this, okay, what we've talked about to now is inputs. That's things the ECU is reading, not things the ECU is commanding, okay? The last part of this, ECU wiring for basic folks, don't let me lose you, is a digital pulsed output. A digital pulsed output is basically, it can either 12 volt, like fire 12 volts out to turn something on, or it can fire out a ground to activate something that already has 12 volts. For example, an injector. Your fuel injectors are 2 wires. One side is 12 volts, the other side is a digital pulsed output that is grounded. When you need fuel, it goes bing, grounds it, injector opens, fuel sprays out. Super simple, digital pulsed output. The most complex is like a drive-by-wire, which uses digital pulsed outputs. It has an AVI. It has all sorts of weird stuff going on, which I'm not going to dive into the dirty details of that in this video. But ECU wiring for basic folks, that's generally how it works. You put the sensors on the engine. The ECU reads the data from the sensors. Tuned by Sean Harness communicates that data from the ECU to the chassis, and also gives us information from the chassis to the ECU, so we can do all sorts of cool stuff. So let's see where all this stuff is out on the car and build us a real trick harness. From the ECU under the dash, the main chunk of the harness comes out of here. I do have some wires that go in under the dash, which I'll explain in a little bit. And then I have a section of wire right here that runs out through the fender and up here. It's actually part of this. And then there is this DTM 8-pin connector right here. This 8-pin connector comes from the factory ECU box, but it doesn't come from the ECU itself. It's more the power and everything for the ECU versus just like sensors on the OEM RX8's engine. So from here, I've added some wires back into the ECU harness. So the harness you're seeing is a flying lead harness for the Haltech S3, and it doesn't come completely built. So I've added these yellow wires here, my 5-volt references, and these black with white stripe wires are my signal grounds, and I've added all of our respective 5 volts, signal grounds, everything for all of my sensors. I've had to just splice them in, make little nice heat shrink 1 to 4 wire connections. The routing I've chosen is back behind the intake manifold. I'm going to have one leg of wires, which will be this leg. There's going to be a breakout right here. Some of them are going to go down the transmission, O2 sensor, reverse lights, and the others are going to come forward right here. So I have 6 injectors. We'll have all of those injectors right here. Haltech does a nice job. They're blue wires. So I've added from over here, these solid blue wires are injector power. So the injector requires 12 volts, and then the Haltech itself uses a digital pulsed output, a DPO, in order to ground the injector to make it fire fuel. And then these other wires right here, the small bits coming up, the longer ones, are coolant temperature sensor in the back of the water pump housing. My fuel pressure sensor goes right here as well. And then the signal ground and 5 volt for the oil metering pump stepper motor. Moving to the far side of the engine, I have another leg. Comes up right here under the oil filler neck. This leg houses a main chassis ground. It also has my combination oil pressure and temperature sensor. Coming up even further and going down towards the crank angle sensor, this shielded wire is my crank angle sensor, which will be installing a full function engineering Hall effect sensor on this, and I'll outline that in detail here in a second. And then also I have coming up to the front a 12 volt source for my MAC valve for the boost controller, which is going to live right down there, and a 3-wire sensor right here for the exhaust manifold pressure, also from Full Function Engineering. They're super nice filter and sensor with their little routing. You can actually kind of see the little bung right down in there. Whoop-ah. On the turbo manifold for the exhaust manifold pressure sensor. So that's just reading the pressure between the turbine and the engine so that we can see if we have any back pressure or flow issues. Coming around even further, these random wires right here at this breakout, so the harness is going to split at a breakout. This is my flex fuel sensor, and then going down to the bottom down here is my ignition coil wiring, and I kept my drive-by-wire cables separate. Now this could be a little bit of a hot topic, but you're going to see that I have shielded wire ran to my drive-by-wire. The 2 AVI, so analog voltage inputs for the drive-by-wire, I swapped out the knock sensor wires here to the AVIs, just repin the connector, because I have heard having noise in your drive-by-wire system can cause it to do weird things, and it might as well just go ahead and shield them. Haltech included the knock sensors. We've got a rotary. If it knocks, it's already blown up, so I just repurposed the wires for that whole situation there. This Tune by Sean harness plugs in to the factory ECU location, which is right here. And I haven't hooked these wires up yet, or terminated them. This big group of wires is what the Haltech is going to see from here. So imagine all that connected. Now I'm not going to go through every single one of these wires and what they do. Sean can outline that for you whenever you buy this. However, the thing that is important for you to note for this area, okay, is this little 8-pin DTM connector that I put on here. This is where I'm pulling the power for all of the systems in the Haltech, okay? The Haltech needs 12 volts to turn on. We need 12 volts to our injectors. We need 12 volts to the ignition coils. We need 12 volts to our MAC valve, our flex fuel sensor, all of that stuff. 12 volts to turn on the alternator, because the alternator wiring on an RX8 goes through the engine harness. In this harness, this DTM connector replaced this giant clamp style connector. It's got the big plastic clip on it that locks down. This is the RX8 engine harness. The body side of this, we cut that off. I put the 8-pin on there. What this has in it, there's 5 or 6 wires in here. 1, 2, 3, 4, 5. This is going to power everything. These are factory fused power wires for the existing injectors, the existing ignition coils, and an auxiliary 12 volt power that I'm sure they were using for the APV or the OMP or something like that, different power. Your reverse lights also run through this. That's why I've got the reverse lights going through there. But cutting this off, repurposing this giant ugly connector into this nice waterproof DTM connector, I've rerouted that power into my Haltech. So those blue wires I just mentioned for the injectors, those 2 power wires, come from the factory RX8's injector power right here. There's a fuse and a relay over there in that factory fuse box. There's no sense to add another one, right? Same for my ECU power comes from here using that auxiliary 12 volts, and my ignition coil power, I split it into 2 wires, and I've got 2 wires running all the way over to the ignition coils, One wire will power the leading two coils, the other wire will power the trailing two coils. There's not really any reason to separate them other than instead of running one bigger wire over there and then splicing it into 4, I just ran 2 wires and I'll keep them separate. Yes, it makes my harness thicker, but who cares? So that's that stuff. The rest of these that Tune by Sean's going to go through with you, really the important ones, if you're doing a swap to a non-rotary or like a non-Haltech ECU, you don't necessarily need all of these, but some of the examples, the factory RX8 fans get actuated through here. So the Haltech tells the Tune by Sean harness, which then tells the car, hey, let's turn on the OEM RX8 fans. The Haltech also tells the OEM RX8 fuel pump to turn on. So we'll be using one fuel pump on that circuit, and I'm going to be adding another fuel pump additionally that the Haltech will trigger completely separately from the car. But another example of what's in here. Some of the outputs from here that are really cool, like your cruise control activation, the CAN bus, also the clutch pedal switch. So I can set it up that when I have the clutch pedal depressed and you go 100% throttle, it automatically turns on a 2-step or a launch control or something like that. The Haltech will see that data. The other cool thing is with that CAN bus connection in here, the Haltech is actually going to have access to the body control module, so it can see all 4 ABS wheel speed sensors. It can see anything that the chassis side does, the Haltech can see that data. You just have to set the ECU up to see it. So a simple example is the cruise control settings, right? Like Sean went through and showed me basically when you hold the cruise control button down, I can have that as a long depress. So if it's held down for say 6 seconds, right? It automatically turns on an anti-lag, a rolling anti-lag, or if it's depressed for just 1 or 2 seconds, like to turn on and off, it turns on cruise control. So that's the cool part about the RX8 versus some of these older chassis that we've all been playing with, up to now, is that this has a lot of modern stuff, and I'm not going to equate it necessarily to like the Motex that people are putting in Dodge Vipers and all of that, but this is like the Wish.com version of a Calvo Motorsports Viper with all the Motec integration, and when you're like hitting the paddles to change maps and the tachometer moves to different spots to tell you how much horsepower you're making and all that stuff. This is like, we're just tickling the surface of being able to play with that stuff. So I'm going to get to hooking up wires. This is relatively straightforward. Put your sensors on your engine, route the wiring harness where you want it, cut it all to length, get ready to put the terminals on it, loom it how you want it to look, put heat shrink on it, whatever you want, and you'll end up with a harness. So that's going to end the Mr. Rad, the teacher, Dr. Rad portion of the video where I'm going to kind of outline this stuff. And for now, let's just have fun building the sweet harness for the RX8. So I know that sounds like a little bit of an understatement, that I'm having fun wiring my car. The hard part about doing a wiring harness is that there is no crazy cool cinematic part of assembling this harness. It's literally 7 hours of me moving around, zip tying, setting the wires in their location, making sure stuff doesn't rub, making sure it's not going to melt, and that I have enough length to get to all my sensors. That's basically what I'm doing right here. So I hope at this point in the video I haven't lost you, and you're feeling inspired to be willing to do this yourself on your own car. Whether it's an RX8, a V8 swap, a rotary swap, a K-series, most of this stuff, each individual system, your fuel pressure sensor, is a very simple thing to understand. There's just 8, 10, maybe 12 of these little systems. So if you're going to do it by yourself, take your time. Trust me, you can do this yourself. If there's anything I want you to take away from this video, you can learn this. Don't be intimidated by wiring. There are tons of people out there who will sell you a pre-built harness and you can go that route. But if you want something that's clean, you're on a budget, you don't have a couple $1,000s to spend on a wiring harness, don't be afraid to do this. And if you have questions about wiring, standalone wiring, consulting, etc., hop over to the Rad Potential Patreon and I would be happy to help you with wiring your car if you have any questions about setting this stuff up. Because all I really want you guys to take away from this video is that you can do this yourself. I want to inspire you. Try it. Don't be afraid of the wiring. Get out and just put your car together and make it run and have fun. Literally, Mazda, GM, everybody from the manufacturer, electrical tapes their harness together. You can do that and it's going to work just as well. So take some time, do it yourself. Hopefully you're inspired. Here's my harness. It looks pretty good. Wiring is probably one of the most fun things that you get to do on a car. For most people, they're gonna hate it. But for me, I just enjoy the tediousness of making a well-engineered and well-thought-out harness. Now, I'm not motorsports F1 professional build your harness guy, okay? I am a split loom from Amazon, not a Ray Kim DR35 heat shrink guy. I just get the stuff I can afford. Amazon special heat shrink, it works great. It does get a little stiff, so I kind of like bend these to where I need them to go, you know, as they're going on the car. The reason being is I'm just trying to drive my RX8 on the street, and most of your OEM harnesses, like this factory RX8 harness down here, is legitimately wires wrapped in electrical tape. Like, that is all it is. And that harness lasted what? This is a 04? 21 years. That harness ran this car with no problems. So I think my heat shrink might be a little bit overkill. And, you know, my recommendation to you guys that are stepping into this room for the first time ever is, like, don't overthink it. Just build the harness. Mine has probably 8 or 9 harness builds worth of experience into it. Trust me, your first one's not going to be perfect no matter how much research you do. So I want to bring you guys in close here and show you a couple things. Obviously, I've got this leg finished, my ignition coils, the drive-by-wire. I've got the end for my exhaust manifold pressure sensor and my MAC valve terminated. That's this like long wire that runs all the way to the front. I'm getting ready to work on the trigger, which is an important step for me to show you because I think this is probably the most confusing part of it. The rest of it's fairly simple, but there's a lot that kind of rides on, you know, basically the whole engine running properly on your trigger settings and your trigger and what crank trigger you have on the front, whether it's pistons or rotary. It's like, this is pretty important. So I'm gonna bring y'all in close and walk you through this. So within the Haltech harness, there's a wire here called trigger. There's also another one called home. If you have the stock FD style front crank trigger, there's 2 sensors. You have to use both of them. You will need the home and the trigger wire. For my setup, I'm running a full function engineering 36-1 trigger wheel, and then their Hall effect sensor. So this is a 3-wire sensor. The factory RX7 stuff, your stock RX8, is a 2-wire sensor. So the Hall, I think, is a square wave, and the 2-wire is a sine wave. There's not really any major benefit from one to the other. They're both going to be equally as accurate. I think, you know, in my personal experience, it's probably a little more pertinent to have more resolution on the teeth than it is to necessarily have like the most accurate, perfect sensor. But somebody could comment below and tell me that I'm completely wrong, but that's just my opinion. So talking with the full function engineering guys, they're awesome dudes. They helped me out with a lot of stuff on this project, and y'all should definitely check out their stuff. They package the stuff super nicely. But this sensor is going to replace the 2, and I'm only going to have 1. So the 3 wires for it. Within Haltech's fancy shielded wire, you want to shield these wires if you build your harness completely from scratch. I think even my Fuel Tech harness has a shielded wire dedicated for this. So, but I did have to add a positive 12 volts. So depending on the manufacturer or the flying lead, or if you're building it from scratch, it's shielded. Fortunately, on Haltech stuff, they have their shielding, and then they have the metal like sheathing around it. The shielding itself is already grounded at the ECU side, so you don't need to ground it on this side. Sometimes, like my Fuel Tech, I had to ground this side of the harness to ground the shielding in order to like cancel out all the electromagnetic interference and stuff that goes on. So once you've stripped this back, there's gonna be 4 wires in here. We're not gonna use all of them. So we've got yellow, green, red, and black. The black wire, ground. The red wire is 12 volts from the Haltech. And then we're going to use the yellow wire as the trigger, which is the trigger plus. So if you look at, and I'll put a screenshot of it on the screen for you, Full Function Engineering provides a complete diagram and all the setup stuff for installing their sensor with a Haltech, including some like starting timing numbers and everything. It's really, really nice. And you'll see for their Hall sensor, it's trigger plus, and on the Haltech, trigger plus is the yellow wire. So the green one we can just terminate and basically roll it back in here. We're not really going to use it. I don't like to cut wires and leave them open. What I'll tend to do is take this wire right here that I'm not going to use. I'm going to fold it back into the harness where the end of it isn't around anything, and then heat shrink that so it's covered. So it's away from all of my connections that I'm making out here, or the pins of the harness, and it's not just chopped off right by the shielding. So same for, I don't really know what other situations you would use that in, but if you're gonna terminate a wire in the harness, make sure it doesn't touch anything. So I'm gonna show y'all assembling this little DTM connector. Right here you can see the wiring for this. Full function positive, full function negative, 12 volt. We're omitting the green. This is the trigger. You could technically wire this up on the home if you wanted to. There from the Haltech, it's the same. You just have to assign it in the computer, but the trigger works best. It's easiest. Here's that wire up close. You can see the aluminum shielding here and the metal cable that's kind of wrapped around this. It's like wrapped in a basket. The green we're not going to use, so I'm going to go ahead. This shielding, I'll just trim that off with the scissors real quick, and we're going to put the ends on each one of these. So this is your kind of standard DTM connector. Nothing really too fancy. Got to be careful if you do buy the Amazon DTM connectors. They are giant in comparison. So like this right here is an Amazon 2-pin DTM style China connector, and this is the actual Deutsch connector here, 3-pin versus 2. These will work. They're cheap. They just, you know, they're cheap. They're bulky, quick to make. So in this sensor, typically most stuff's always told from like looking at the back of the sensor. This is simple because we have 3 wires coming out that are already colored, and then we're gonna effectively be plugging this in like this. So we know that my red needs to line up with the red. The white with black is gonna be my trigger sensor. That needs to line up with the white with black, and then the black is the ground, which needs to go to the ground in the harness. So we can basically go ahead and just throw all 3 pins on. These are these little DTM pins. Some of them are a concentric style crimp instead of like a side style, so you can look here. This crimp, the little circle one, has its own special crimper. You can get this on Amazon, like a whole kit of these for like 20 bucks, different sizes. And then the style that this connector uses, we'll use a crimper like this. Or at least this is what I used to do them, which is proper. So, strip the wires back like that. I like to give them just a little bit of a twist. You don't have to like sit here and make these into a little tornado of wires. But just when you cut them, the ends tend to flare out. So we want to make sure we're not going to have a flare out there. Grab our little wire. Grab a little tool. Get it started. I always do there's kind of 2 sections in here. It's going to be hard for me to show you. But there is the back crimp there, right here, and the front one. This back section goes over the insulation in the wire. So we go ahead and get that in our crimper on the right size. We'll just start with the positive. It literally doesn't matter at this point. Lay that in there so it's far enough that we're going to catch the insulation. Crimp that down very gently. You can mess these connectors up very easily, so just be real careful. And then we'll go ahead and crimp down the wire section next to it, and make sure you don't crush the actual bullet of the terminal itself. And just like that, we have one finished crimped pin. So you can kind of see here if I lay this in here real close. That is how that needs to sit. So notice that would be the wire all the way out of the terminal. The wire sits up in the terminal. Enjoy my beautiful fingers and thumbs. All right. Now we got that in there, we'd be ready to put our connector on. We've got to go ahead and slide this little insulation on here, but also this is the perfect time, since I want to cover this up. I'm actually going to shorten this just a smidge so I know it fits under my heat shrink. What I like to do is we'll take a piece of heat shrink here, slide this back. And there's 2 reasons for this. One, try to keep all the water you can out of these whole situations. So anytime you're going to have like wires like this all be exposed, you want to make sure there's no water. This heat shrink has like the glue in it. The other reason is this gives you a place to grab. So if you click this, you have a nice kind of even area where you're not pulling hard on any one pin or the other if you have to unplug something. Make sure I got that in the right order, huh? All right, so if we go in like this, we have red, ground. I need to switch those. The trigger goes in the middle. So just like that. 1, 2, 3. This is where having that heat shrink loose is nice. You can slide it back. Get this little waterproofer on here. Just like that, we know our order. Pop this off. These connectors are fairly simple to take back apart, so if you do put these in wrong, you can pop them back out. Click, 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 click. See right there, we've got them all situated. Might have to little push up there. Verify that we're right. Red, white, black, red, yellow, black, same thing. Let me take the plastic retainer and come on, this can be a little tricky. There we go. Ooh. There we go. Always like to not really push against the connector, but hold the connector, push with my finger, and make sure I'm not pushing the wires back out. That snaps in, should be able to see them all right here. We slide this up in here. And then I would now take my heat shrink and slide it up over the end of the shielding. Come on. So to right there, and we're gonna heat shrink that down. And now just like that, I can take my Hall effect sensor. Such a satisfying sound. Plugs right in. This sensor obviously get mounted on the front of the engine. I've got to do something to cover up these wires. I don't really like how exposed, you know, for this short length of me sucking to get this untied, but this section of wires, I don't like that exposed, so I'll probably slide just some split loom on there, you know, this piece right here, something like that. And then I've got some bigger heat shrink I can probably get over this connector. Really my only complaint would be like, I probably ought to de-pin this connector really quick. Just pop these out of here. I'm gonna need a different, oh, this will probably work. If I grab this, pull that out, and then, where are the releases? See, now I gotta make sure I get this one all plugged in back right, you know, to match the other side. But if I de-pin this, and then I should be able to get, I just like when you put this loom on here to heat shrink the end, so that way the water doesn't get down in there. This side's obviously completely waterproof, but just to cover up the part where you're gonna be grabbing it all the time. The loom is loose, you know, it's gonna move back and forth on here no matter what. You're not gluing it to the wires, and like all those Raychem craziness, guys, it's like you could just grab this and like hold the car by it and it's not gonna, you know, rip the wire. But effectively, if I take this little section, honestly this will work. It's probably the right length. I did not cut this pre-talking about it. I was just like, oh, should probably do that. But this whole length of wire is gonna run up the front cover, and there's just a lot of activity happening up there. You know, you got pulleys for the air conditioning, power steering, ignition coils for me, my fuel system, alternator, you know, a lot of stuff that should I shred a belt, it could tear this up. So you really want to make sure this wire is protected. There isn't a whole lot of noise in that area, so you know the alternator, whatever you're using to charge your battery, wire could be close. And then we'll take this. I could pop this orange thing off of here, but if I do, it's going to mess up the orientation of the wires, so I'm gonna leave it on. Slide the heat shrink down like that. I'm gonna go ahead and just re-pin this real quick so I don't forget which order this goes. So that goes that way. Which means these go in here like this. Red to red, white to yellow, black to black, all good. Unclip that. Snap all those in. The female side of these is a little bit harder to do because you gotta like really look down in there. And then you pretty much have to have some sort of a small needle nose pliers. I don't have fingers small enough to get this retainer down in here. Snap that dude back in. Give it just a light tug, make sure they're locked. Put that back in there. And now I can heat shrink that. And voila, we now have our full function harness all tidied up. A professional would put heat shrink on this end as well, but I mean, if I have something tear that up, we're in bad shape. So there we go. Full function engineering trigger kit, wired up. So got to install it on the car and get the tooths and get the teeth all set up and everything, which we'll do in the startup video. That's when you'll see this harness get used. But for now, I have completed my ignition coil is the drive-by-wire, the alternator excite wire, which turns that on, the trigger, boost controller, well, Mac valve, and then my EMAP sensor is all wired. I have to loom this. The other thing to keep in mind too is like as you're building one of these out, notice I've got like these big pieces of heat shrink at the breakout points, so where I'm starting to split my harness. It's really nice to be able to take two legs, so like this and this are separate, right? Drive-by-wire ignition coils, and have a piece of heat shrink that holds them together, so you don't have, basically you just don't get any fraying. And I want to try to minimize the amount of electrical tape on my harness just because it always falls off and gets annoying. The heat shrink is semi-permanent, but this harness, as I built it, if I have an ignition issue, that's a pain in my butt to fix. But for the sake of the main trunk of the harness, if I need to add things to this later, it becomes very easy to add wires or change stuff within the harness. When you order one of those mil-spec $10,000 Rob Dahm spec full-on like harness, which is awesome, you have to have so much forethinking, like thinking ahead, such that you don't mess it up. Because if you have to modify a Raychem glued harness with all the boots, you might as well throw it away because you have to pretty much start over. So this is a good, you know, enthusiast level DIY harness. It's going to look really nice in the engine bay and function for probably longer than OEM, but I like to change stuff, so it'd probably get changed sooner than that. So I'm going to sit here and finish this. Injectors, oil pressure, oil temp, fuel, flex fuel sensor, OMP, O2 sensor, reverse switches, fuel pressure, coolant temperature sensor, intake air temperature sensor. And then I got to do the stuff inside the car, which is super easy because it's like one big DTM connector that I can add and subtract to for the fuel pump trigger and a couple other things that I'm not using. I'm just going to go ahead and wire them to that instead of just pulling the pins. And then the other connector is my trim for boost control. So I'll show you it whenever I'm getting closer to finishing this up. Excited. Chuckles, what do we got?
We've got wires.
I got a harness. I'm super pumped with how this came out. That's kind of my running theme of all my videos, is that I'm super stoked always. This is literally, I'm really impressed with myself, honestly. There's only one spot that I really kind of messed up, and I should want to see if you can find it. Where do you think I miffed?
So your harness isn't done.
No, I'm not going to heat shrink the ends. Because if I heat shrink this close to here, if I need to make pins move,
I guess
I can't do it. If I leave this open like this, it's under the dash. Like if that's getting wet under the dash, we got problems. Yeah, I'm not gonna have a short down there. Yeah, water coming in. I'm okay with this. You won't see any of that stuff. I've got some electrical tape in a couple places. The only thing that I missed is right here.
Oh.
So on this sub harness that's coming at the base of the intake manifold right there, I forgot to put a big piece of heat shrink at the base of where that leg was gonna come out. So I didn't get to do like what you see here with the nice heat shrink to the two things clean. I just overshot it. I forgot to put one in here. I needed one around this group of wires, and I didn't have that. But yeah, I'm super pumped. Look at this. This is that crank trigger I was showing y'all earlier that we did together, and here's where the little breakout is, and then go back a little bit, and I got a breakout for the grounds. And my oil temperature and pressure, flex fuel sensor, it just had to come out all by itself right here. No big deal. There, O2 sensor, all my injectors, I did do, the primaries are gray, so they're easy to discern. And then the secondaries, because there's 4 of them, are all black. But the primary secondaries, so the center iron ones are black, and then the long ones are the outers, the true secondaries. And I tried to scribe a number. It's hard to see those 2 marks? That means in rotor 2. I actually tried to draw a 2 on one of these, and I don't know which one it is, this one. And I ended up drawing a 5 because I was looking at it upside down, but I thought I was looking at it right side up. Happens. So that was like scratch marks, and I was like, oh, scratch marks. We'll just put 2 hash marks for everything. And then honestly, the most complex, which I said about the beginning, is the oil metering pump plug. It's got 7 wires coming out of it. 3 of them are like the sensor for the stepper motor, and then 4 of them are the stepper motor controls. And I wanted to maintain the OEM oil metering pump plug so that I don't have to like cut an oil metering pump apart to put it on here. I can just use any factory pump and it plugs right in. So this is like I used one from a nicer FD harness and cut it off and then just spliced it in. I didn't actually pin this plug out from scratch because I'm sure I could find it, but I just honestly didn't look and I want it done now. So that leg is what goes to the factory ECU plug-in under that aluminum panel.
Nice.
What do you think?
I think it's good.
It looks pretty nice.
I think the car's coming along just, I mean, awesome. It looks incredible. So, and we just ran through some like paint ideas.
Yeah.
Color scheme ideas on what to do with everything, and I'm pretty pumped to see this thing all in its final form, and you know,
Rip it across the country.
Ripping across the country in a cannonball, or you know, just ripping around town.
Yeah, I think really it's the first time this video that he's seen it
Mostly complete.
Yeah.
Yeah.
Because there's a lot of little stuff. I was pointing out, it's like, oh, I didn't even notice that, or oh, I didn't even see that. Like, for example, the thing I'm the most proud of is my shaved power steering pump right here. It looks OEM from like 6 feet back.
Yeah. Not even 6 feet back. I mean, I was standing right here and didn't notice it.
Yeah. But we're gonna lay this harness in here, and I want to see it all in here, all dialed. And then the next video, we're gonna build out all the fuel system, and then rip it all back apart, clean some stuff, put it all back together, fire it up, tune it, cross-country road trip.
And then rip it all apart.
Yes, we gotta take it apart again, build the engine for 600 horsepower, paint the engine bay, the whole car, put the... We got a lot of work to do. Needless to say. All right, let's drop this in here. What's gonna be really fun is all of that needs to go up through here.
I was going to ask which hole or how that was all going.
Behind the intake. Look at that. Through my fingers there.
Here. Oh my, there's a lot of that.
Oh yeah. Yeah, unfortunately we're too close to the firewall to just like
slip it down.
Stick it through there.
You want to under that brake line?
Yeah, under it. I didn't want to run the big plug.
Mm-hmm.
This wire goes all the way up here to those. And then my trigger wheel wire, either all that's probably going to sit right under there.
Mm-hmm.
Grounds. Kind of need that to like spin. Flex fuel, will it reach? Barely. If I do a 180 with the flex fuel sensor, it'll be easier, but then it doesn't sit as flush to the firewall.
Okay.
Right there, ignition coils. I'm not going to plug all of them in, but they go there. And then my drive-by-wire, which I left long in case I change stuff.
Okay.
I figure it would just live somewhere out in the middle of its own nothingness.
Yeah.
The other thing is, like, apparently, I'm not an expert on this yet, but your drive-by-wire systems, if they have like noise, they'll act funny, much like a trigger noise. So I ran shielded wire for these. So I left it long in case I had issues and I needed to fix something, but I don't have my injectors in, guys, so I can't hook up my injectors, but apparently, or basically, these two will be down like that. These two will go straight, so we'll just put all four of the primaries straight. Come on. I'm hiding these pretty full function engineering rails, all these wires. And then that one would go back there, and that one would go right there. So like this is gonna be, I mean, that's mega concise right there.
Yeah.
You grab the camera, bring y'all close. So here's the layout, guys. Wiring up here to boost controller, the MAC valve under there. EMAP, super nice, it'll go under the aluminum. Drive-by-wire here. You can see my routing, almost like I had it when it was bare. That's a little unfortunate, but this will slide right through here. Still see the top of the engine, injector wiring and everything sits nice and concise over there. Reverse wires, and then the O2 sensor, which Haltech does this thing where they send you this like O2 sensor adapter harness that is literally 5 feet long. So this plugs into that, which I'm gonna have a bunch of it. And then that'll run down to the O2 sensor, which is actually in the mid pipe, not the down pipe. It's right at the base of the down pipe, but it just worked out better to actually put it in the rest of the exhaust. But ignition coil wiring way down there too. Looking clean. Dude, I freaking love it. This is a serious machine right now. This is a serious machine. Sick. And then on the inside, Oh, I got stuff everywhere. Right there is my ECU. There's the wiring to it. And then these longer leads right here that are laying down. I've got a CAN bus wire here for the IC7 display. That wire's that small black one right back there. And then that one that Calvin just grabbed is actually for my boost control trim switch, which I haven't decided where I'm gonna put it. And because street car, I might just put it in the glove box. And you might just have to open the glove box and then make a little panel for it to mount like off the side of this, just so it's right, literally like right here, twisty twist. And then we can turn the boost up and down. Sean was telling me that I can actually program the IC7 to do my boost control. So I could use the plus and the minus up here on this to actually turn my boost up or down. I don't know if we'll experiment with that or not. I can always reassign the trim switch for traction control or for something else, but it's just nice to have that option. So while I'm in here building the harness, might as well set it up for it. Sweet. All right, well that's the wiring harness video, guys. I hope you guys learned something, because building out a harness is not as hard as you think. Take your time, build your diagrams, science it all out. Pretty easy.
Yeah.
Pretty easy.
It was easy for me. I just showed up and it was done.
For sure. So with that, thank you guys so much for watching. We are one step closer to the Cannonball run, another step closer to getting this thing running. And I think I've impressed Mr. Chuckles.
Oh yeah.
I don't think this is what he necessarily expected this to look like. This is a serious machine now. It is by far the best car I've got after this. It's the one I probably paid the least amount for.
It's gonna be tough to rate it above the RX7 because it's kind of like its own thing.
I know.
Granted, this too is its own thing, but you know, compared to the RX7,
it's gonna be a good
two
car.
very high quality builds there.
The amount of things I've learned on this that I would redo on that is already off the charts.
Yeah.
So thank you guys so much for watching. Live a life you don't need a vacation from, and keep it rad. And at the end here, a huge thanks to Tuned by Sean, Full Function Engineering, JDL Manufacturing. Go check out their stuff. If you're at potential patrons, go check out their stuff. Chuckles for just coming out and helping me put my finished wiring harness in my car. Also the Cannonball Run co-pilot, and here is the mess of the aftermath. My camera ran out of storage space, so I'm going to narrate over the end here. Thank you guys so much for watching. Live a life you don't need a vacation from.